Show here, a lot of them are taken from a book called Working Effectively with Legacy Code by Michael Feathers. How many of you know this book? Okay. More of you should know this book. Okay? This book is worth its weight in gold. Okay? This is one of the books that for me helped to clear a lot of the techniques that I've been using. So I owe a lot to Michael for writing this book. And it's the reason I asked him to write the foreword for my unit testing book. So the first refactoring and the easiest refactoring you can make is extract interface. And a lot of you probably already did it. However, in legacy code situation, this is also the safest refactoring because it changes very little in terms of the structure of the code and the signature of the code being used. And if we talk about legacy code refactoring, we have to consider two parties. We have the party that you're changing. That's the class that you hate. But then you have all the classes that already depend on the class that you hate. They will hate you back if you change the signature. So changing the signature is one of the worst or hardest things you could do. Not necessarily worst. We're going to see some patterns for also changing the signature. But in terms of ease, you want to change the signature less. Sometimes changing the signature is a great idea, but it takes a long time because there are a lot of people or classes depending on it. So extract interface. Here's a simple example. Let's say that you have a class called storage. Storage takes an email sender as a parameter to the constructor. Or maybe it doesn't even take a parameter. Maybe it just uses new email sender at the beginning. And you want to test that storage actually sends an email when you call save. But the big question is, how the hell are you going to do that? Because email sender is a hard dependency and it actually uses the real system. There is no way to replace it. So one way to replace things in languages like .NET and Java is to have an interface. So we create a new interface in the system called iEmailSender with exactly the same signature. And we replace the signature of the constructor in a way that doesn't hurt everyone that depends on it. Because email sender will also implement this interface, so we just add to email sender. Everything else that uses this class will not have to change. But we get what's called a seam. Seam, S-E-A-M. A seam is something that allows us in our code to test or to replace things. And in this case, having a parameter that's an interface into the constructor allows us to create, in our test classes, a fake email sender. So in our code, in our test code, we could create a new class that implements from iEmailSender as well. However, it will not really send an email. It will just simply implement the interface, and when someone says send email, the send email class will just be an empty class, and we'll just save the values. So it's a fake email sender. Now, we can use this one and send it into storage, and storage wouldn't be any wiser. It will just work the same way it did. Production code will work the same way it did. So we refactored the code. So what's the definition of refactoring? People. That's why we pay you. Okay? Yes?
Same functionality, just structured another way.
Same functionality structured another way. That's a great definition. So changing the code without changing the functionality. Perfect. Pay this guy. Now this is important because when we refactor, the last thing we want to do is change functionality. Because that's a very risky thing. We usually don't have tests. But if we had integration tests, checking the functionality, we might catch it, but it's still a very risky thing to do. So changing functionality is something that we only do in a test-driven way. Changing the structure of the code we can do without adding specifically new tests. Here we're changing the structure so that we can add new tests, and so that later we can add new functionality. For example, email sender needs to be called twice, but I want to write a test that it's only called that it should be called twice that fails. because it's only called once currently. So for that, I will introduce a new interface, create a fake email sender, and then I can write a test that says that fake email sender should be called twice, but it's called only once. Okay? And then this test will fail, and then I can add the new functionality which calls it 2 times. So there is a process here. Here's an example. Class storage takes an email sender. We change the constructor so that now storage doesn't care what is the type of email sender that it has as a private variable. And it takes an interface as a parameter. And then in our tests, I can basically send in a new fake email sender and then call save. And then I can test the result, or I can assert on something here. This is the fake email sender in my tests. So I can actually do nothing, or I can save the message here, put it in a public variable, and then assert on it in my test. I can create this on top and then assert against it at the bottom. So I can use it almost like a spy that says, hey, go in and tell me what happened to you. This is me using the theme. However, when we introduce this interface, and what I notice is that a lot of teams, they see extract interface and everything, they have a hammer, everything becomes a nail. And so you see these systems that are very, very, very testable, where you have hundreds of interfaces all over the place. Almost, the worst case is where someone almost created an I integer, But think about it, is that this becomes a bigger problem over time. In this case, person logic, maybe or storage, takes 2 interfaces. So now in the code, everyone who uses person logic now has to create 2 objects in order to create person logic. That's easy. But what if to create a logger, you also need to create another couple of objects, because each object has its own dependency. What if to create a logger, you need an exception handler and a data writer? And to create a validator, you need to have an I overridable somewhere in the dependency. And to create the handler and the overrider, you need 3 new dependencies. So now to create this simple person logic, you need 9 lines of code in your production code just to create this thing. So now you have to create these factory methods. And that's okay too. But this is where things like dependency injection containers come into play. And they help a lot with this problem. So there are a lot of inversion of control containers in .NET. The 3 that a lot of people I see using is structure map, unity, and ninject. However, your mileage may vary. Has anyone here ever used one of these or a different one? Which one have you used? Castle Windsor. Castle Windsor is an older one that's very widely used, but it's a bit long in the tooth in a way. So it's getting older in terms of API, and the new ones have a better fluent API that to me is nicer and easier to understand. A lot of times, especially since some of them are inherited from Java, you have to configure them via XML, and I hate XML. So a lot of the new ones, including structure map and inject and unity, you can configure directly via code with no configuration whatsoever in files. And to me, that's much more maintainable. So here's an example. If we have these two dependencies, we could create a container. Now this is a test that uses the Microsoft Unity container, but you don't necessarily want to use a container in a test or in production code directly. You want to usually abstract it away. But this is to show how you use a container. So in this case, the Unity container from Microsoft, which is an open source project, you call register type of iLogger, set it to fake logger. So if I think about it, it's really a smart factory method at the beginning. You say, look, when someone requires a type, and that type needs an iLogger, give them a fake logger implementation. When someone needs a person validator, give them a fake testing validator. So now if I want to create an instance of person logic be testable, which is from my demos, I say unity container.resolve and give me an instance of this. I don't say new, I just say resolve to the container. And the container will take care of everything that's going on in terms of dependencies. And if you've been to one of Mark Siemens' talks, he has a tool called AutoFixture for unit tests. And AutoFixture, in a way, works the same way, is that it allows you to not think about the signature of the constructor of an object. It will just fill up what's necessary with default fake objects for tests. In this case, this is something that we might use for production. So in production, we wouldn't use fake logger. We would say, if anyone in our production code ever wants a logger, they should call resolve, or whatever the infrastructure forwards to resolve, and say, give me something that looks like a logger. And if logger has a dependency, and the dependency has a dependency, etc., recursively, this will just work in a single line of code. And that saves a lot of typing time and understanding. This also gives you very nice flexibility, because if tomorrow you want to add a new dependency into your code, you simply put it in the constructor. And if the container is already configured to use that dependency, this type or interface, then you automatically get it. You say, oh, I need a service configurator. Put it in the constructor as a parameter, and at runtime magically you have it, because someone calls resolve, container already knows how to give an iService something, and you don't have to change the signature of anyone that calls you. So it does give a lot of flexibility. So if you do a lot of extract interface, at some point you might have to start facing the reality of IOC containers. Now, I personally have not used them too much. I find that when I have a lot of these parameters, I tend to group them all together into a single object. So common refactoring that I do is when I have 3 parameters or more, I create a single parameter of an object with those parameters as properties. Okay, that's called parameterized constructor, or create a method object. Not method object. I don't remember. I not remember. Sorry. Okay, so when you do talk about containers, you shouldn't use them directly in production code, because there is that creates another dependency on something. And the whole point is that you use containers that you stop wanting dependencies. So it kind of defeats the purpose. Some people say, oh, and then it will be harder to change a container later. I've never seen a project that wants to change a container after a year. Okay, the next piece of code is a different kind of refactoring. It's a bit more advanced in that it requires a bit more understanding in terms of inheritance, etc. Extract and override. How many people here read my book, by the way? Just so I know. Okay. So you got the book. That's a good first step. Okay. So extract and override is, you see all these words written here? Forget about that for a second. I'll show you a demo. What should we do? Login manager, LM with statics. Okay. Yes. Okay, so here's an example of extract and override. Extract and override is powerful for almost any situation. That's why I call it excrack and override, because it's almost too easy to use. At the beginning it looks a bit convoluted, but when you get used to it, it's very simple. So here's an example of a method called isLoginOK. It takes a user and a password, and it has a dependency on static logger. Now I want to write a test that proves that it calls the logger, but logger is static, I cannot replace it, and I'm not using a tool like type mock isolator or moles or anything like that. How do I do that? And the answer is I cannot without refactoring this code. So how can I refactor this code to test that the static logger was called? I can refactor it into one more level of abstraction. And I'm going to say this. If we have this line, I can extract a method I can make it virtual, and I can call it call logger. Okay? However, it's not good enough yet, because this method, because it's virtual, what's going to happen is that in my tests, I will want to override this. That's why it's called extract and override. I'm extracting a method. This method calls directly to the static logger. But I also want to test the variables being sent. So I'm going to extract a parameter here. I'm using, by the way, ReSharper. Who has ReSharper installed? Okay, who knows more than 50% of the shortcuts in ReSharper? Okay. If you have a tool and you don't know all the stuff that you can do with it, that's a waste. Okay. Probably 90. Okay. So let's say login requested. I'm going to change it to text. Now I already extracted this message. I'm just going to use the one I extracted before, but it looks exactly like this. Now you can see that I refactored the code, but the functionality has not changed. So if I go back to the what the hell? If I go back to the usages of the code, I can see that we just have this call logger with the variable, and that's very good for me because I don't want to change the functionality. However, I've created a seam. So if I had a seam before where I had an interface I could replace, now I have a virtual method that I can override. That's a different type of seam. Okay? So if I go to a class and I say login manager, LM with tests manual, login manager with statics, manual tests, and I create a class called testable login manager with statics. Let's do that all over again. So let's say I create a class here, class testable version of login manager with statics, inherits from login manager with statics. Now this is important. I'm extracting, I have to override it somewhere. So what I'm going to do is I'm going to create the exact login manager with statics with only one method being fake. To do that, I override call logger. And I don't call the base. Now what happens is that production code calls logger, but logger doesn't do anything. So maybe I can do something here. I can say maybe create a public property and say text written equals text. Let's do that into a field, create field, and make that into a public. This is what I did now. This is all I have to do right now to create a testable version of login manager with statics. Now I have to use it in my test. So I'm going to create a new test here. Test. This is, by the way, a macro that you can do in ReSharper. This is the macro that I use to create my unit tests. If you want to know how I do it, just let me know and I'll show you. Okay, one person, not enough. And unit of work is the thing that I'm testing on. So I'm going to say is login okay. This is the entry point of my unit test, the public method that starts the unit of work, the use case. And I want to test that it always calls static logger. What else? Now what I'd like to do is to say var lm equals new testable login manager with statics. So instead of creating the actual login manager, I create the testable version of it. And I can count that the testable version works exactly like the real one because it inherits from it, with only a single method turned off. Then I can simply say lm is login OK with a user and a password, and assert is not null for lm.textWritten. So I'm actually asserting on a property on the object I'm testing, but the property is only specifically from the test domain. So in production, this text written thing doesn't exist. This only exists in my test domain. So I created a testable version of this. So again, what I did is that I created a virtual method that I can override in a testable version of the same object. And then I used the testable version of the object with the logger turned off to check what text was being sent to the logger. Okay? It seems complex at first. You have to do it a couple of times. What happens is that once you do it, you get the hint of it, and then you can break almost anything with this thing. Almost anything. Questions? Okay? Okay. That was the easy stuff. Let's talk about okay. Just like we extract and override a call to a logger, we can also extract and override a call that creates an object. So let's say that we have a dependency on an email that gets created directly in the code. So we have a workflow engine, and in the workflow engine, we have new transaction manager being created. And to create it, you need a new model reader and an XML store. And all that stuff is a bunch of dependencies. It's very, very difficult to actually test this. And this all happens in the constructor. So even creating this class has a dependency on the file system. So it can't really be a unit test. And it requires us to have configuration files in the right place. And maybe use a lot of app settings to do stuff. So we can take this whole selected piece of code and extract it into a factory method that is virtual, that we can override. This will not work in C++, by the way, but it works perfectly fine in C#. So instead of all this stuff, I created a protected virtual make transaction manager. It works exactly the same way. I did not change the functionality in any way. However, it's virtual. So in my tests, I can now create a testable workflow engine. And in the testable workflow engine, I can override making a transaction manager and return a fake one. And now I can maybe assert things on it or recreate conditions. For example, how can you test what happens when your code encounters a memory violation? So I can make the fake transaction manager do whatever I want. It's my code. It's in my tests. I can put whatever fields and booleans on top of it. It's my own class. So extract and override works for creating objects. It works for calling objects. It can also work for future objects. So this code hasn't been created yet, but I can control the instances of objects directly created through refactoring methods. I can return different objects. I can return the same object. I don't really care. Questions? Okay. Here's a simple one, parametrized constructor. So parametrized constructor is something a lot of us take for granted, but sometimes in legacy code, the dependencies are created just like here. We have the transaction manager being sent in, not being sent in, but created. But we could just as well create the parameter for the constructor and make it a dependency that you can send in or inject. So you can create a constructor injection pattern here, just like we did before. So we can create an interface or just create the class and make it a parameter, and then make the class an interface. Here's one a bit more interesting. Breakout the method object. Breakout method object. Let me see. Breakout method object. Breaking out a method object is what you do when you have a public method that uses a lot of private methods. This is example, by the way, is in C++. I hope you guys can still read it. I know it looks like a bunch of characters swearing in The Simpsons or something, which is the reason I don't like C++ so much. However, it's a good example because here we have a class called GDI brush and we have a method called draw, and it uses a lot of private methods and it shares the same variables and the same fields with it. And that creates a very tough thing to test, and the class is very, very long to test. So instead what we could do is we create a whole new class called renderer. And the renderer will take the original class and all the variables that the public method and all the private methods used, and it will use them as fields in the new class. So we create a class just for that one public method and all its private methods. Because what it does, this way it allows us to test just the functionality of that method without interfering with all the other methods in the class. So we end up with a class that looks like this. We have this method draw. It actually calls the renderer, and it calls draw on the renderer. So this is the method that can actually be tested and this method has all the private methods that it needs, but none of the other methods from the original class. So it's cleaner. Okay? So if a method uses 3 or 4 sub-methods in the class and the class is huge, you take one method at a time with all the things it relates to and put them in a separate class. And you make all the variables it shares in the class as public fields or private fields in the new class. And then the original class just calls the new class in a single line of code. That makes things much more testable, cleaner to read. Okay, adapt parameter. Let's see if I have. Okay, adapt parameter is one of those signature changing techniques. Now, the signature here has to change if we want to cover one of those solid design principles that you can hear about from Uncle Bob. Let me show you the principle itself. It follows the interface segregation principle. And the idea is that no client should be forced to depend on methods that it does not use. So let's say that your method relies on HTTP context. In this case, this is Java, so it uses HTTP servlet request, but it just might as well be HTTP context. HTTP context has how many methods, do you know? 117. I have no idea how many, but definitely around that. And here, in this class called ARM_dispatcher, it only uses a single method of that class to do its bidding. So what we do is we say, okay, let's use the interface segregation. We only need to use a single method, and that gives us the ability to refactor and wrap it in an interface that only has a single method. So we can create an interface called iParameterSource, which has a method called getParameterForName. And iParameterSource will use the HTTP servlet, and it will use whatever it needs inside it, but it only has this one method. And inside it will use whatever servlet method it needs. And this is important because this means that we wrap the dependencies of our classes with only the methods that are needed by those classes. So it's easier to fake. For example, it's much harder to fake a class or an interface with 100 methods than an interface with a single method. Okay? And if tomorrow we don't rely on HTTP server but on something else, it's very easy to change the production code, but our tests will not break. So the more chatty our interface is, the more likely we will want to change the signature and say, we don't need something with all those 20 methods when we only use 3 of those. Let's create an interface with only 3 of those methods, or maybe a single one that uses those 3 as an adapter, and use that one in the new class, in the class that we're testing. And again, if there are any questions, just let me know.
This exercise, is it only for testing purposes we do this?
No, this is not necessarily for testing purposes. This is basically a design technique, although it helps with testing.
But often you use, for instance, standard .NET objects.
I would.
Does it make sense to wrap all these?
Does it make sense to wrap? Well, sometimes it makes sense and sometimes it doesn't. If the interface is very chatty, there is a big chance that tomorrow someone's going to use another extra method just because they can, and then you have to fake another method, and then you have 50 breaking tests. So in terms of maintainability, it can help you a lot. Because in terms of maintainability, you wrap this whole thing in an adapter class. And then the adapter class only has a single method, or 2. So it's much easier for testing. So but as a general rule, you're going to have a harder time or more brittle tests when you use fake objects that have a lot of methods. It doesn't really matter if it's .NET or not. Okay, even if it's your own classes and they have 20 methods and they only get used by only 2 of them get used by by an object, it usually means something. It means that maybe you don't have a single responsibility principle in those classes. It means that that class works both as something for this class, and the other 18 methods work as something different from another class. So it usually means you want to break things up. But at the very least, you want to adapt a class specifically for your class. So it's a single responsibility principle as well in action here. Other questions? And then in your test, you can create a fake parameter source that you can fake the value to return. You can create a new fake parameter source, set the property to return whatever you want, and that gets used here. Now, static setters are something that a lot of us are afraid to do. So imagine you have a simple singleton class, okay? Here's a singleton class. Not a very good implementation, but who cares? Singleton is a singleton. Who knows what a singleton is? Okay. For those who don't, a singleton is a class that only has a single instance, and it prevents you from creating new instances of that class. So in this case, it's message router. If I want to use its instance, I would say message router.instance, which is a static method that automatically creates a message router. And it has a private constructor, so I cannot create it directly. Now in this case, the big problem is, what happens if message router has a dependency on the file system or configuration files or all that stuff? How can I break those dependencies? How can I create my own fake message router if someone else is using it, or I want to test if message router gets called? One simple way to do it is to not just have a public getter, but also to have a public setter, which of course defeats the whole purpose of a singleton, which is why a lot of people don't like it. But I don't have a problem with it, because I'm not religious about these things. However, for those people who really, really care that, and they're afraid that their users of the API will use it wrongly, you have to remember 2 things. First of all, if you are only relying on your API, unless you're creating a framework that's going to be used by people all over the world, if your framework is going to be used only by people in your company, and you're not sitting with them and doing code reviews, and you're just relying on your API to tell people how to use your code, they're going to misuse your code anyway. Second of all, one of the nice lessons I've learned from other people is that when you leave things open, you're going to get nice surprises of how people use your API, so that they use it the way they need to use it instead of the way you designed to use it. And it helps them even more. So if they can override things that you didn't even plan that they can override, that's not necessarily a bad thing. You think it's a bad thing because in your head you're a control freak. But having overrideability for things you cannot even imagine now that will happen in 2 years is something that I really like having. But let's say you still don't want to do it. This is what I would do. Instead of having message router instance, I would put a public setter called set testing instance. I would have the word testing in there. And I would put the conditional on it. This only gets compiled if the unit test or, let's say, debug compilation flag is on. And this allows me to only have this during running tests. And it doesn't actually get included in production code. Simple. This way everyone's happy. I'm happy because I can test this thing. Control freaks are happy because it doesn't exist really in production code. Questions? Okay, now here's a complex one. Instance Delegator. Instance Delegator is, this is the one place you're going to have a hard time if you get out now, just so you know. Too late. There is this pattern that a lot of actual users of ReSharper like to do, and that is to let ReSharper dictate whether a method is supposed to be static, etc. And so you get all these statics all over the place. So here's an example. This is from an open source project called blogengine.net. And blogengine.net, somewhere deep inside it, has a static class called manager. Why is it static? Nobody knows. What does the static actually mean on classes? Do you know? All methods have to be static. Why do all methods have to be static? Nobody knows. So you actually remove room for methods that are not static in this class. We'll talk about why that's bad. And then you have a static send method. Okay? Now just to explain, the manager has a send method that takes an iPublishable. Look, it's an interface, everyone. And iPublishable is a blog post. And then it has a bunch of stuff, like it looks at the blog settings, instance. Notice how that's a singleton right there. I want to test the send method. I want to test, for example, that when there are URLs in the item content that I send in, then if the blog settings is true, then it does something. It calls something. But everything is static here. I cannot use extract and override. For example, this method here is private static. Now, private static is an example of someone who just extracted a method and it's static by default. But if it was an instance method, I could make it virtual and then I could override it and fake the URLs from the content. I could also, if this whole class was not static and this method was an instance method, I could extract this whole thing into a virtual method and say fake that blog settings returns false or true by extract and override on this piece of code. But I can't because this method is static. So we cannot use virtual methods. So there's nothing I can do to replace anything. To be able to even start refactoring and replacing things, I have to make this method an instance method. And for that to be an instance method, it has to be a non-static class. So in this case, I wouldn't have no trouble of removing the static keyword. It doesn't change the signature of anything. No code that uses this class will break. It doesn't break. This is only an implementation issue of this class. And it just hurts our testability. Let's see if I can go to manager here. And what we want to do is to try to refactor this. And so what I'm going to do is I'm going to create a forwarding mechanism into an instance method. Now remember, one of the worst things I can do is to change the signature for everyone else who's already using this class. So my primary purpose is to make this testable and still keep the signature. And this miracle can happen if I remove the static keyword and I duplicate the method. So I have now two methods called send. Now compiler won't let me do that, so I'm going to say send internal, or maybe send instance, and this one method is not going to be static. Now this is the original method, and I made it non-static. What about the static signature? It's going to be a forwarding mechanism. It's going to say new manager dot send instance of item and item URL. This is the beginning of my refactoring. So I've made the class an instance class. Everyone else who's already using the static method will still be able to use the static method because the functionality has not changed. Everything that happens is that now it uses an instance, and that instance still uses the same exact methods. Look at this. Right? This is not an easy method to test, but I can now that it's an instance method, I can start taking advantage of things like extract and override, because now this method is running in an instance of a class. So for example, let's say this is a dependency, obviously. This is a singleton. Let's say I want to make sure, without needing a configuration file in my tests, that enable trackback send is always going to be true. So I can extract and override this stuff into a method. Control-Alt-M in this case. Make a method, make it not static, make it virtual, and now it looks like this. If enable trackback send. Now in my tests I will have a testable manager class that overrides enable trackback send, and instead of this implementation it will just have a field that I set in my test to return true or false or whatever I care. So now I have full control. So from being a fully untestable piece of code, this has now become a very testable piece of code. And now what about all this stuff? Get URLs from content. This is a private static method. Private static means that nobody else is using it. So there is no harm in me removing the static. There's no harm. Nobody else is using it. Only instance methods, which they don't mind using static methods. And they're only in this class because this is a private method. So there's no harm in removing the static and making it virtual and making it protected. Like this. Now this allows me to do more cool stuff like fake that I have 2 URLs in the content or 0, etc. Instead of creating content with URLs that are very, very complicated, I could just return whatever fakes that I want. So again, what I did is that I took an original static method, I created a copy of it, I made the original non-static. And the copy of it, I simply forwarded to say new class called the non-static version. So now I have an instance delegator. It delegates the call to an instance with exactly the same parameters. And that gives me the flexibility to extract and override or introduce interfaces or whatever I want. Questions? Yeah.
What if there was some kind of member variable inside that class that was static, that needed to be static, because let's say some data was fetched from the database that you want to make sure it was only fetched once and was reused again and again while restoring your member variable.
So what if there was a member variable that was static that you needed in this class?
That you wanted to set from the database but only once, and then you would not go to the database anymore, you would retrieve that value from the static, so it really had to be static. And would you have an issue, because now you started making things into instances instead of being static?
So I'm not sure that I understood the end result that you're looking for and how we would refactor, but usually with a combination of either extract and override or extract the factoring method of the thing that you're trying to get, or just having control of public setter on the static member that you can control, then you can get around those things. But I would have to look at the exact code. Maybe you can do it after the talk.
But you understand the
I don't understand the exact issue, but I don't want to get into it too much now, but we can do it after. Because it sounds like it's a bit more complicated than this, and this is complicated enough. Okay? But I haven't seen yet an issue that I cannot overcome with the combination of these methods. Okay? Other questions? Okay. Let's see. Okay. So, in summary, what I want to say is that legacy code is hard, alcohol is good. However, all the refactoring stuff that I just told you about, you cannot do them without the acceptance test. So if there's one thing that you have to start with, is not even do the refactoring. Overcome not overruling, by bypass all the refactoring and the unit testing stuff at the beginning and start with acceptance testing and see what you end up with. You might end up with exactly what you wanted, which is a tested system that you can change without going to the trouble of refactoring the hell out of it later, because then you can refactor it to whatever you want. Not just for testability, but just for better design, whatever you want. Testability and better design are not necessarily the same thing. They don't always mean exactly the other. Okay? But they sometimes overlap. So don't mistake testability with great design. Okay? Design is a separate skill from writing unit tests.